Log is short for logarithm. Okay? Logarithm. And there's different types of logs, okay? We're not going to use that button just yet because there's many different types of logs. That button that you see is one specific type of log. Okay, so there's a bunch of different kinds of logs that you can have. That button there is one of them, okay? So for a little bit, you're not really going to use your calculator too much for this. We'll show you how to do it without it, okay? But pretty easy though. Okay, so logarithm of the base of b. This slide looks confusing, but it's not really too bad. What you back up, what you want to do is you see down here in the symbols, I would get this right here. And I would take it and write it out like I'm about to do somewhere else. Log little b. Notice how everything's written, okay? Notice how the b is down below here. Okay, that needs to be the case when you write it. I need to make this just over here just a little. Move this up just a little bit. There we go, that's better. And let's move this. Everybody got that wrote down? Okay, let's actually take, hold on, done. Let's make this less clustered. Let's put this somewhere else. Boom, that's what I wanted. That's sweet. There we go. Alright, cool. Everybody got that? Okay, let's start labeling parts. What does that look like? What? What? What'd you say? Well, that's a lie, but okay. B, what would the next, if I was going to read that right side, what do I say? B, what? To the, right? B to the power of y equals x, all right? So whenever you say b to the power, this b here is called your what? Right here, let's start this easy. This y is called your exponent, right? A little hard to see the light blue, let's change that. Better? Yeah. Okay. That y is your exponent. Okay? X is just your answer. So then what's b? Anybody know? The base. Good. Okay? Base. Alrighty. Okay, that's the base. That y is the exponent. Now let's put it over to the other side. What do you think this b is called? Everybody want to take a guess? Base. The base. Good. All right. Anybody want to take a guess where that y comes from? It's the wrong color. It's the exponent, right? And then x is just x. So you can see how, and then you add the log in, okay? So the log base b of x equals y. That's how you say the left side. All right, log base b of x equals y. If that's the case, then b to the y power equals x. All right, so everybody got your calculators? All right, I want you to do, how do I want to do this? Actually, never mind. I don't want to give it away yet, just yet, so we'll get there. But you can switch these forms, okay? And switching these forms from what's called logarithmic form on the left. Let's write that down. Logarithmic form on the left. To exponential form on the right. Okay. Logarithmic form is the left, where you have the logarithm in the equation, right? Log is there. Exponential is on the right, where you don't have the log, but you do have a base to some exponent. Okay? But the parts are interchangeable when you go from one form to the other, and that's the important part for today, because we're eventually going to get to equations that let us solve using this switching property. Okay? Any questions? Everybody okay? Everybody got that down? Okay, let's start. I think it's easier to start going from logarithmic form to exponential. Okay, so that's what we're going to do. So I'm going to make one up. Ready? Let's have log base 3 of 9 equals 2. Okay, so here we're going from log to exponential. Alrighty, from log to exponential. Now, this little 3 down here is called what? The base. Okay? It's the base in your logarithm, right? Log base 3. Whenever you switch to exponential, this 3 is going to become your what? Your base. Except this time it's not going to be the base of your logarithm, it's going to be the base of your exponent. So that is the most important thing to remember. Alright? So then that 3 becomes the big 3. Now, the rest of this, honestly, for training purposes, you can make sense. Okay? You know you want to go from here to something to some power, right? Okay, so which power are you going to put on 3? 9 or 2? You're going to put 2 on there, right, to make it a true equation, right? So 3 squared is going to equal 9. Try it the other way. 3 to the 9th is not 2, right? Okay? And then since you're going from logarithmic to exponential, you no longer write log with it because you're not in logarithmic form anymore. So that's it. So 3 squared equals 9. Done. Let's try another one. Let's try log base 4 of 64 equals 3. What's that one switch to? 4 cubed equals 64. Okay. Does that make sense? Okay. You take the base of the log, make it the base. This jumps over here. This jumps over there. Okay. So now, instead of doing ones that fully make sense, let's go and move and do a couple that may not. Okay, some of them still will. So here's these 4. Okay. Alright, so write each log in exponential form. First one, log base 2 of 8 equals 3. In exponential form, that would read how? 2 to the third equals 8. Good. Log base 4 of 16 equals 2. How would that be? 4 squared equals 16, okay? So the ones you know, that makes pretty easy sense, right? And you can always go back to that if you need to. But you are going to eventually get to ones where you may not know it, so you need to know how to do it just looking at it, okay? So the base on this one becomes the base of your exponent. This 6 goes to the exponent, and then 729 goes to the other side. So 3 to the 6 equals 729. What about the last one? What's next? To the negative fourth equals 1 over 256. Good. Okay. All right. You need to know how to do that switch right there. All right, so that's one way. Everybody okay? Now, let's go the other way. Okay, this one's a little harder. All right, going from exponential to logarithmic's a little bit tougher. All right, so here's what I would do. If we're going from exponential to logarithmic, sorry. If we're going from exponential to logarithmic, what do we know is going to be in the problem, in the answer? What word?
Log.
Log. Okay. If we know we're going to logarithmic, well then guess what? Log is probably going to be in our answer, right? Okay. Now, the base of the exponential becomes the base of your logarithm. So what's the base in this first one? 15. So 15 gets rewritten down here by the tail end of the G. That's where it goes. All right. Now, what do you do with the 3 and the 3,375?
You put 3,375 equals 3.
Good. You switch them. All right. Just switch their places. 3,375 equals 3. So that's how I would start that. I would put in, so like for the next one, I would put log first. All right, the base of your exponential becomes the base of your log. So your base in this one is, what's the base on this second one? 4. And then 64 and 3 do what? Switch. Okay, next one. Log. What's your base? 4. Then what? So it becomes log base 4, 2 equals 1/2. And then last one. Log, what's my base this time? 125. What's next? 5. Okay. Even though, let's talk about this one real quick. Even though your base is really big, like write the number 5 after the base, kind of, even though it's lower. Okay. Don't put 5 like up here. Okay. So just write the base out lower as a subscript. Put 5 next. Equals 1/3. Oops. That's the main points of today, is making sure you know how to do that switch. Okay? Questions on that? Okay. Now, with this comes figuring out what these are, or equations like this. Everybody good up here? Comes with evaluating these guys, getting their numbers without using your calculator, okay? Because like I said, you can't just do the log button that you see, okay? That log is very special to one kind of log. There's many kinds of logs. There's an infinite number kind of logs. All right, this one's the 16th different kind because its base is 16, okay? The one on your calculator is specific to one number, and that's it. All right, so in order to do this, evaluate log base 16 of 4, we're going to set this equal to a variable. You pick your variable. I like x. Okay, next thing you're going to do is you're going to switch. You're going to switch forms from logarithmic to exponential. So 16 to the x equals 4. Okay. Now, what does that look like? Huh? It looks like what you just did, right? So 16 you can rewrite as 4 to the 4 squared to the x equals 4. What's the exponent of this 4? What's the exponent on this 4? 1. So 2x equals 1, so x equals 1/2. I'm going to mix it up. Ready? I'm going to choose y. Okay. So 3 to the y equals 81. What base of 3 can you rewrite 81 as? 3 to the 4th. Good. So 3 to the y equals 3 to the 4th. So y equals 4. Okay. And the last one, I'm going to go way off the wall. Ready? Triangle. Log base 1/2 of 256 equals a triangle. Solve for the triangle. Ready? Do your switch. Okay, so 1/2 to the power of triangle equals 256. What do you do next?
You break down.
Good. So 2, in my case, to the negative triangle power equals 256. Which means 256 needs to be able to be rewritten as a base of 2, right? So 2 to the negative triangle equals 2 to the what? Is it 2 to the first? No. 2 to the second? No. 2 to the third? No. 2 to the fourth?
Is it?
Isn't it 2 to the 8th? Yep. So negative triangle equals 8, which means triangle equals negative 8. Or, A or B or Y or X or Z or whatever variable you choose to use. For whatever reason, I chose triangle. It's all good, though. You can do whatever, okay? Your assignments on page 401 is 13 through 31 odds.